Hey guys, we have been working on missing addends. Do you remember what a missing addend is? It's when you're missing one of the numbers that you're supposed to be adding, or you're missing one of the parts. And you've been working on pictures of dominoes where you can see one of the parts, one side of the dots, and you're trying to add more dots to figure out what the missing part was. So you know one of the parts, you know the whole, but you have to figure out the other part. We can also practice that using a part-whole mat. Some of you will start using that today, and then some of you will wait and use it in a couple days. So this is what a part-whole mat looks like. It has, let me fix my pen real quick. It has a top part for the whole, and then it has two bottom parts for the parts. These two bottom sections are the parts, and they are the same as the whole when they're together. See how these two boxes, when they're together, are the same as that top one? Because when your parts are together, they should be the same as the whole. This is a lot like a number bond. You have your parts right here, and when they're together, they equal the whole. So the part-whole mat is the same idea. You have your whole at the top, and then your two parts are down here at the bottom. So if we had 8 and 5, you know that the whole is 8 and one of your parts are 5. It's your job to find the other part. So 5 plus something equals 8. Do you have any idea what the other part is? 3. The other part would be 3. 5 plus 3 equals 8. All right, so that was pretty easy, right? Let's try something a little trickier. Let's imagine our part-whole mat, and this time our whole is going to be 12, and one of our parts is 8. So 8 plus something else will equal 12. So 8 and something else together are the same as 12. How can we figure out what goes with 8 to make 12? What strategy could we use? Counting on. Now, when we were using the domino, that was super easy because you could draw more dots as you counted and then count how many dots you had to add. This time we're going to try using our fingers to help us count on. So we already have 8. We're going to imagine the 8. And then we're going to add more until we have 12. So we have 8. One more would be 9, 10, 11, 12. So how many did we have to add to get to 12? 4. The other part was 4. So 8 plus 4 equals 12. We just counted on. And you could even draw your dots to check if you really wanted to. So there's my 8, and there's my 4. Let's count them all to see if it really is 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It worked. Counting on works. All right, let's try another one. Use my eraser hand. All right, so I have my whole in the top. This time my whole is going to be 13, and one of my parts is 7. So 7 and something else would be the same as 13. 7 plus something equals 13. What do we need to do? Let's count on. Okay, so we already have 7. One more would be 8, 9, 10, 11, 12, 13. So to get to 13, how many did we have to add? 6 more. So 7 and 6 would be 13. 7 plus 6 equals 13. What strategy did we use? Counting on. Very good. Ooh, let's try another one, and I'm going to try to be a little trickier this time. See if I can trick you. Okay, this time my whole is going to be 15, and the part that I know is 9. Oh man, my missing part is over here now. So something plus 9 equals 15. Oh no, the missing part is the first number now. What am I going to do? I'm still going to count on because one of my parts is 9 and something else needs to go with 9 to make 15. So I already have 9. If I had one more, how much would I have? 10, another one, 11, 12, 13, 14, 15. How many would I have to add to get from 9 to 15? 6. So the other part is 6. 6 plus 9 equals 15. And if you're not convinced that counting on still works even when they're flipped, we could draw 6 dots and 9 dots and count them all. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Because in addition, there's a rule that says you can flip the addends. What's that called? Flip, flop, commutative property. So this and this are the exact same thing. So if you would count on from 9 to 15 to get this, you could do the same thing for this one because they're going to equal the same thing because of flip, flop, commutative property. Let's do one more. What do we do? Let's count on. Let's start at 8 and count on to 12. 8. Now don't put a finger up yet. You only get to put one up when we actually make a jump. 8, 9, 10, 11, 12. So what's the missing part? 4. And we know we can count on because missing part, more missing addend plus 8 equals 12 is the same as this. And so if this is 4, then this is also 4 because of flip, flop, commutative property. Now go work on your missing addend paper. Good luck.